classic problem in computer science, the flood fill algorithm. So let's see what it is. An image is represented by an m by n integer grid image where image I of j represents the pixel value of that image. You are given three integers SR, SC and color. You should perform a flood fill on the image starting from the pixel image SRSC. To perform a flood fill, consider the starting pixel plus any pixels connected to 4 directionally to the starting pixel of the same color as the starting pixel plus any pixels connected 4 directionally to those pixels also with the same color, and so on. Replace the color of all the aforementioned pixels with the color that is passed in the function and return the modified image after performing the flood fill. For example, this is what you are given. This is the image that you are given, 3 by 3 matrix, and the starting pixel is this middle M, which is colored in this yellow. So what you need to do is you need to color all its adjacent 4 directionally connected means up, down, right and left connected pixels of the same color, that is those pixels with the same value as 1 to the color value that is in this example which is given as 2. If we see here, we can see that 1 is connected 4 directionally to this cell, this cell, this cell and this cell. But if you check, we can see that only the up and the left pixels have 1 as their value. The rest is 0. So this is turning out to be a very simple breadth first search algorithm. Classic matrix problem like this, before doing the BFS, we need to have a total row count and a total column count, which will be equal to length of the image and length of the first row. Sorry. We should also have the starting color stored, which will be SR and SC. So this will store the starting color. This is to check before coloring if you want to color it actually or not. Because if you're encountering a 0 as in this example, which is not equal to 1, we don't have to color that. Then for doing a basic iterative BFS algorithm, we use a data structure Q. So let's initialize a Q with a starting value of SR and SC. So we are already populating it with that first cell value. So we can start from there. And we also need to maintain a set of visited cells, because once that cell is colored, we don't want to recolor it again. So we just need to move on from there. And that cell, it is already considered visited. So we will add it, repopulated that visited set with SR and SC. Since in a matrix, we also need to have the directions, because this one will have up, down, left and right connected cells. So we need to go and check each of these connected cells. So let's create a list for moving up and down. This will be up. This will constitute the right side. Now we'll have a down and then we'll have a left. So just consider it as XY axis. This will be up, this will be right, this will be down and this will be the left. Okay. Now going into the queue, we will start our BFS algorithm. For ij equal to, we are getting the first cell that is in the queue. When this line is first run, I and j will be populated with the values of SR and C. So we don't have to actually check if that cell is the required color, because since we are starting with that color of the starting cell, it will be always of that color. So we can go ahead and recolor this as the color that is required to be recolored. Now we have to move around and see. Move around as in move up, down, left and right, and see if we have the cells of the same color as the starting color. In direction, we need to get the cell indices first. So I plus di and j plus dj. This will ensure that we are moving from I, j, we are moving up, down, left and right of that cell with the indices ij. And then before coloring, we need to check if that index that we just now got is actually greater than 0, because index will never be less than 0, right, in a matrix. If less than greater than 0 and less than the total row count and we have to check for both ni and nj if they are actually within the limit of the matrix indexes. And also we need to check if this particular cell is already visited, then only we need to recolor it. If it is not visited, it will not be in the visited set. So if it is not visited, then we need to go and check if that image color is actually the color that we are looking for, that is equal to the starting color. Then we will recolor it. Then we will add it to the visited set. Okay. And then we need to add it to the queue as well, so that in the next iteration this particular cell's neighbors will be visited. Then we need to, so we are supposed to return the modified image. We will return the image because we are modifying in place. We don't have to have a new matrix initialized. We can return the same image. Let's run and see. Oh, there is okay. Yeah, this length function in Python is len. Okay, and here it should have been a comma. Okay, the two test cases are accepted. Let's submit it and see. Let's talk about the time and space complexity. The time complexity of this algorithm in a worst case will be big of n, where m is a number of rows and n is a number of columns in the image. This is because in the worst case, we might have to visit every single pixel in the image if they are all connected and have the same starting color. We'll check what is the space complexity. Also be the same of mn. The queue used in BFS in the worst case will hold all the cells or all the pixel values if they are all connected and need to be processed. And also the visited set will also contain all the pixels in the matrix.